Thank you. Thanks, Chris, and good morning, everybody. It's a real pleasure to be here, to see many new faces, but some old friends as well. David's always a tough act to follow, but I'll try to do my best. So this morning, I wanted to think about what I was going to say. Like many of you that give a number of talks, the horizon of the talk really comes to your mind about 48 hours before you have to give the talk. I thought of multiple things I could say that might be relevant to the SRII mission. I could talk about technology. I could talk about kind of trends in the marketplace. I could talk about the changing face of users and uses. I could talk about the change in geopolitics that govern where our industries and our markets are going to go. And I could do all of that, and they would all be relevant, but I don't think they would be critical to the mission that we all collectively in this room are going for. The second thing is I'm not an expert in any of those. There is one thing I'm an expert at, is simply being a citizen of this world, living in the times that we are, and dealing with its opportunities and challenges that we all face. So, armed with the belief that if anything that I was an expert at, it was being a citizen and absorbing and living in this world of today, and the fact that I wanted to think about something that was critical, not just interestingly relevant to the mission of SRII. I chose a particular topic for this talk, which in itself sounds a little strange. And when I sent it to my legal department, which we all have to do to give external talks, they said, "What the hell are you going to talk about?" Right? What I want to talk about is jumping off of where David gave me a wonderful segue of a second economy. We think of it as, or I think of it more as the coming economy as we look through the various phases of evolution of our planet and its economic system. What do we do in that knowledge economy, which I will talk about, that has a stronger sense of democracy? Not a political democracy, not a cultural democracy, but really the notion of an economic democracy. Because at the end of the day, if information technology is to become more relevant, more critical, and integral fiber of our lives, the word "our" has to encompass every person living on this planet. So with that, I'm going to put forward some thoughts. I hope, if anything, that there's things that you will agree with. I'm sure, things you will disagree with. But if I can at least get you to think about these in the context of the various topics I saw on the agenda that you're talking about, whether it's big data, whether it's services, then I feel I would have achieved my purpose. So with that in mind, let's go to the first foil. I talked a little bit and introduce this notion of a knowledge economy. But let's go back and talk about what's going to be, where did we come from in the process of getting to this imminent dawn of a new economic model. Historically, I saw equity as wealth. And having been born and brought up in India, I'm sure this is not unique to India, but where the economic, I would call it class system, is actually quite clear. My view of historical equity and historical equity in a particular economic framework was simply wealth, money. You had the haves on the top, you had education. I was privileged to be a member of society where my parents and family had the ability to give me education, have money. We didn't have slaves. I don't know why we put the word slaves up there, but we had various stratas of society in support of our lifestyle. We had land, we had means of production, military power, but these are all assets that drove a class system in the economy based on wealth, based on things that you either gathered or you procured, and then you could protect by putting a sandbox around it, typically called a bank account. And the have-nots simply didn't have it. Right? They lived in the same society, but this notion of have and have-nots was based on the equity being something that was physical, something that was manageable, and something that was protectable and associatable only to you. And you use that equity only for you. You were not dependent on others as much in how you protected and used that equity. Well, I assert to you that the future is different. The next global equity is knowledge. David talked, and I'm sure others have as well, of this notion of knowledge as a service, if you will, delivered as a service, becoming critical in multiple aspects of our lives, whether it's enriching our lives in the area of healthcare, our financial stability, to even at the, not just the personal level, but at national levels or country levels, being integral to the way economies are monitored and run, national security purposes. It is at multiple levels. Knowledge is becoming the most important equity that differentiates competitiveness of nations and individuals. And I think this is not nothing new, as in it has come to the fore today. This has been gradually building. We've certainly seen this in the personal domain, where in many places people have invested to earn more knowledge. The more education you got, typically it was correlated with better opportunities in life. And that has simply scaled beyond a single person, a single community, to national and even global levels, to the extent that you can start to see many, many countries in the world starting to invest in growing their knowledge equity base, just like they would grow their foreign reserves or deposits, and attract investment of wealth. They're attracting that on the knowledge space. You start hearing about things like the brain drain or the brain reverse drain. You start to hear about infrastructure to build up knowledge and to supply a knowledge economy with essential ingredients, which is data and information. So if this is the world we are getting to, why do we think it's going to be possible? Why is it that knowledge is going to become one of the fundamental things that people, communities, and nations thirst for? Well, from our perspective, by 2015, we will clearly have more than 1 billion netizens, right? Against a potential population of 6+ billion or 7 billion in the world. These more than 1 billion, and some argue whether it's 1 billion or 1.5 or 2 or 2.5 billion, but a significant percentage of the world's population are going to be netizens. There will be 15 billion connected devices in the world of various classes, but they will be connected as in participating through the transfer of information and data and the delivery of service in the knowledge economy. David talked about everybody's car with FastPass being a supply of data into a service that essentially improves our lives. 15 billion is more than in 2015 than the population of this world. So think about the implications of multiple devices per person. And probably the result of more users and more devices is really on the right-hand side, which is more data. More than 1,000 exabytes of data, whether it's in personal data created, whether it's data created in the Internet of Things, whether it's simply model data or physical data, we will have, and whether it's just transferred over the traditional internet or it's sitting locally stored waiting to be used, data is going to become the next abundant thing in the world. The engine of the new economy then has to be, if technology is going to be a democracy driver in a knowledge economy, it has to be available to anyone, anywhere. Otherwise, we are starting to again look at the next phase of this planet's economic model with haves and have-nots. That data that I talked about and this notion of not making data the next bank account, that is, you hold it, you can only use it for your purpose, and it's nicely segregated from anybody else's data, is really in this notion of how you harvest data to create knowledge. Data in itself is quite useless. It's bits. How you correlate that data, and this is really some of the big data analytics domain problems that many of us are looking at, you turn that into information. From information, you glean a view of the future, which is knowledge. Data is very specific to one thing. What's the temperature in this room? What's the speed of your car? What's the size of your bank account? Information is context around that data. Knowledge is what could happen in the future that you can apply that data, information, and experience to. And all of that needs a phenomenal amount of infrastructure and capability. And this is where I get to why Intel, and personally why me at Intel. If you look at our corporate vision being the company that we are is not to triple the number of microprocessors we produce, or to simply drive Moore's law down to sub-nanometers, or to build cell phones and other kinds of mobile devices. All of those are means to an end. And for us, in the context of what I've been saying this morning, that end is to create and extend technology to connect and enrich the lives of every person on Earth. It's an ambitious, audacious goal, right? Creating and extending technology, yeah, that's not as audacious. Many of us do that as a living. To connect and enrich, yeah, in different shades and scales and shapes, that's possible too, as technology and innovations make incremental improvements. The big thing in this statement is the lives of every person on the planet. And that comes back to this notion of providing our innovation aspirations a context, an economic and a world context around what we do. We could, if not for that last phrase, we could be in what we would call esoteric or niche technology from an economic sense, from an economic class system sense, from a society sense. We could build great things for a great number of people and completely ignore the many others that had no use for that technology. So in order to kind of connect what I was saying about the coming of the new age of a knowledge economy, the role of data, the ability for technology to actually make that an asset for everybody, and something that everybody will have to participate in and therefore provide value and derive value from, that is to create a society where technology is a democracy driver, because everybody will be needed and everybody will benefit. I want to talk for the next part, a few minutes, about connecting our corporate mission to some of the core things we think are very important to go deliver that. First, realizing the vision and our corporate thing is called sponsors of tomorrow, and in many ways that is connected to this notion of what is the world we build, both for ourselves, others, and our coming generations through the work we do today. From a company's perspective, from Intel's perspective, from my perspective, there are 5 fundamental pillars to achieving that goal of creating and enriching, creating technology to connect and enrich the lives of every person on the planet. The first is silicon technology. This fundamentally is Moore's law. At the end of the day, the transistor is the fundamental tool, and that has become the economic model for the advancement of the information technology train over the last 40 years or so, ever since very large-scale integration started. Continuing to drive that economic law forward, continuing to provide the benefits of cost reduction while providing the benefits of performance is fundamental in order to make things that, again, can be used by everybody in as many situations as possible. The second is, on top of transistors, architecture. And this is a pretty broad word, because architecture is not just x86. Architecture is really the model in which you take multiple capabilities at the silicon level, the circuit level, the physical design level, and embody it in a model of the way a certain thing works, and then extend it, modify it, and enhance it to make it work in many, many other domains through design point optimization. We believe energy efficient architecture is fundamentally important because one of the barriers to making technology as a democracy driver is energy consumption. Second is it has to be scalable performance. This is not just about building servers only or supercomputers or just cell phones. It has to provide the performance that that task needs. And thirdly, which we believe is very, very fundamental to a viable economic model, is it has to be programmable, and I should have said programmable by many. It has to become an asset for the community, an asset for the world, not just a show of muscle power for a few that have mastered the ability to use that technology. So the architecture itself has to be a democratic franchise. Third is network infrastructure. David talked a lot about some of the interesting facets, whether it's barrier to entry, whether it's technical barriers in growing infrastructure as many, many more things compute and communicate in this Internet of Things or this world where data leads to information and has to become knowledge. Those three things are, in many ways, as I talk to people, they tell me that's the geek's view of the world, right? And it is. Geeks are essential, but not sufficient. The other two that are really in the domain of where technology marries with business and reality to create something of value, which is solutions. How do you take these technological innovations and how do you take them into solutions that users touch, use, pay for? And that has a lot to do with how ecosystems get built. How ecosystems have a value chain built in them so people actually do want to and can participate within the constraints that they have. If you do those top three things without this notion of what solutions and the ecosystem for that solution will look like, you will fail. That's been our learning from our failed experiments, and that's been the learning of our industry several times in its effort to go try and test those waters. The final one is investment. None of this is a stationary thing. It's not turn the crank once. David talked about a bunch of areas where there still needs to be a lot of research, whether it's research in fundamentally pushing the technology to its next step, whether it's about taking a technology and seeing how it works at scale, whether it's about investing in business models that have not yet been tried. So unless you layer on top of this the investment needed to not only keep the technology engine running, but the investment to seed and grow the ecosystem of value, of services, of solutions, this will fail. I should have added one more, which then becomes an absolute essential ingredient if you do all these 5, and making the max value out of that happen, which is collaboration. Yes, in our industry, we are fiercely competitive amongst ourselves. That's the natural law of business. But there's just as much need and actually evidence of collaboration, whether it's in standards bodies, to business model collaborations, to legal entities people create, or even philanthropic efforts that companies do. But understanding this fast-paced market that's changing, especially collaboration with the academic world, where there's a very strong force of innovation going on, is actually quite fundamental to realizing this vision. It's fundamental to making everyone to having an inclusive approach. And if you are not inclusive, not only do you lose out on tapping into key assets that you need, but the lack of inclusion starts creating walls when you start to apply and deploy those technologies, and that those walls eventually turn into a force against democracy in a technological society. Why is Moore's Law important? We spend multiple billion dollars a year on simply assuring the world that every 2 years we go to the next process node. The fundamental reason is, if we didn't have Moore's Law, we could still build the chips probably that we built 10 years ago, today on technology that was 10 years ago. And even if the technical people did amazing jobs to build huge packages and deal with power delivery and build server boards or client boards or whatever that accommodated those big chips, the economic model, as more and more people use that, would be dead. And so for Moore's Law, one of the things I like to point out is not so much what it does in silicon, but if you had such a law applied to other areas of the industry, what benefit would it bring? So here's an interesting example of what would happen if you applied it to the auto industry in terms of speed, energy efficiency in terms of miles per gallon, and cost. Right? The numbers are actually quite stunning if all we did was we took the 2-year doubling cadence. What I didn't say here, because that kind of ruins my story a little bit, is if I took size, none of us would be able to get into the damn car if the automobile followed the Moore's Law curve. But this is a fundamental economic statement, right? This is the underpinning of why more and more silicon and digital technology is finding its way and is becoming an essential part of whether, as David said, connecting the physical world to the digital world, or being part of the digital world where it's crunching or communicating data. Energy efficient performance, which goes back to the architecture, built on Moore's Law, whether the design points for what we believe is possible to get intelligent computing and communications into the smallest of sensors that go into agricultural fields or get implanted into hulls of ships or even painted on surfaces to give them an automatic sensing and computing capability, to whether you build supercomputers on a chip, teraflops on a single chip, and replace hundreds of racks in a data center with what looks like a personal computer. All of those are built on this notion of building the right design points of architecture on the substrate of Moore's Law, providing the economic power and performance benefit. And we are, of course, very heavily invested in all of these areas. The net result of this, of Moore's Law and architecture that takes advantage of Moore's Law in an intelligent and scalable way, is what we see as having created a history of transforming industry economics. And if we are going to go into a knowledge economy of the future, And we are going to continue to provide we collectively are going to continue to provide the economic benefits of marching down the information technology path. That transformation will have to happen several times over again. Why? Because of cost, because of scale, and because of reach. It's very fundamental that we continue to make these technologies cost affordable to make, cost affordable to deploy, and cost affordable to maintain. Without that, there is no scale, there's no reach. If there's no scale, there's no reach, the economic value proposition starts getting brittle. But more importantly, from the context of what I was saying this morning, it starts to engender a have and a have-not society in a knowledge economy. So this is just an example of annual server shipments from 1995 to 2010. And again, if you go forward to 2015, every time I stop that graph, it looks like it's done pretty well and it's going to be about as good as it gets. By 2015, we expect a fairly significant growth in server infrastructure shipments, and this is more server specifically, server CPU shipments, driven by some of this transformation of use of data to go to information and knowledge, right? At the same time, what we have to look for is that there's a transformation in the cost efficiency of that technology. So a teraflop of performance in 1997, and the dollars per gigaflop was $55,000 per gigaflop. As we marched, in 2010, you had to be about 500 teraflops or higher to be, you could be on the top 500 for far less, but to be a real supercomputer, roughly in that area, and it was less than $100 a gigaflop. From $55,000 a gigaflop to $100 a gigaflop. Imagine if it had not come down, many fewer people would be saying, yeah, David, wonderful idea with this data collection and a lot of crunching. I don't have a wallet big enough to do all of that crunching. Okay? We are at the same point extending and expanding our investments. As we look at technology and how technology gets used, it's no longer just about silicon and architecture. What we are trying to do is, in this knowledge economy, or help enable this knowledge economy, is not only look at the install base, but also look at the people that are fundamentally going to build on this install base, which is the solution providers and developers of these solutions. Our job is actually to facilitate their adoption of these technologies and their creation of new value-added services as they create the fundamental solutions for analytics, for various kinds of intelligent devices and services associated with that, and the next generations of a software-driven intelligent world, whether it's in-vehicle infotainment, to financial systems, to national security challenges, to simply things that David interestingly called agents, that we could have multiple of those in our lives. So for us, the future of what we think a knowledge economy requires from Intel and the call that we are trying to answer is essentially getting closer to delivering or enabling solutions. 35 years ago, Chris, you were part of Intel then, we had one product. It was called, actually this was after the memory to microprocessor transition, we had a product called the microprocessor. And fundamentally, other than PCs, we had no idea why anyone would want it. Fortunately, PCs did pretty well. Today, our view of the world is very, very different. Our view of the world is, as technology gets more complex, as there's more co-design of technology, of hardware and platform technology with software and applications, as there's more need to understand usage models, not just of today, of the future, you have to start thinking of the world as solutions, or thinking of providing solutions, or what solutions look like, in order to decide what and how you build the parts that you would build in order to enable those solutions. So from processors, platforms, software, and services, including some of the things we've gone ahead in the last few years and made significant acquisitions because we didn't see us being able to grow that organically in the time frame that we needed in order to transform this solution-oriented thinking. What solution says is, don't build a technology and throw it out there. What solutions focus for Intel is, understand how people are going to use this, understand how the various players in the ecosystem will participate, what they will need, and do your part to foster that ecosystem and that usage so that we can continue to move the world forward in this knowledge economy. And with that, ladies and gentlemen, that's all I had to say.